early humans, okay? You do need to know that term, all right? What is a hominid? It's an early human. It's a predecessor to the humans that we know today, according to evolution, okay? Now, if you can see, there's a big line of them, and the farther back you go, the more and more they look like an ape, right? But it does not mean that the apes, the gorillas, the chimpanzees, bonobos, all of those that we see today are our ancestors. Okay, it means that there was an ancestor over here that led, part of it led to humans, part of it led to apes. Okay, but genetically we are mostly similar to apes. Okay, specifically chimpanzees. All right, so here you see Australopithecus afarensis, and then there's one before it called Africanus. And then little by little, genetic variation allowed them to become Homo sapiens, right? So this is natural selection. This is based off of evolution, okay? Now, there are some that you may be familiar with, like Homo sapien neanderthalis, which is this one right here. There is another one that I can't, like the Cro-Magnon man, which is like a subspecies of here, okay? You may be familiar with those. Steve just said that the Ice Age baby, the baby from the movie Ice Age, was supposed to be a Neanderthal, although that baby was probably a little bit too cute to be a Neanderthal.
It's ugly.
Neanderthals were a little bit more like hairy, primate-like. Okay, maybe you guys think it's ugly. I'll say this: it was a little bit too hairless to be a Neanderthal. Neanderthals had a lot of hair. Okay, so it's important to know that common ancestor thing that I told you, the common ancestor thing that I told you, and also our genus species name. What is it? Homo sapiens sapiens. Okay, Homo sapiens sapiens. Okay. That sounds like a pretty good bonus to me.
Homo sapiens sapiens.
Homo sapiens sapiens. Okay. Now listen quickly. This is the last thing we're going to talk about, which is mitochondrial DNA. Okay, mitochondrial DNA is the DNA specifically found in the mitochondria. Okay, it is separate, okay, related to, but separate from the DNA that you find in your nucleus. All right, so mitochondrial DNA is going to be an exact copy of the DNA from your mother. Okay, so yes. So Daniela's mitochondrial DNA is exactly the same as whose mitochondrial DNA? Her mom's, right? Okay. So using this mitochondrial DNA concept, we can trace back organisms to common ancestors, all right? Now, of course, just like any DNA, there is going to be variation, right? But it's the most similar thing that we can get, right? Whereas if we were trying to trace back like the nucleus DNA, it'd be a lot more difficult because only half of that DNA would come from our mother, right? But assuming that our mitochondrial DNA is exactly like our mother's, we can trace it back all the way up to the early humans, okay? So that's what they're trying to do, okay? Trying to find the DNA in the mothers, and then their mothers, and then their mothers, and then their mothers, until we can get to a human like this. Now, this isn't just happening in humans. They're also trying to do this in other organisms because other animals will also have mothers, okay? Just understand what mitochondrial DNA is, okay, the DNA in the mitochondria, and its importance, especially when we're trying to create a phylogenetic tree. Yes?
For the Homo sapiens sapiens, that's humans, right?
That's humans, yes. Homo sapiens sapiens. Yeah, this is Homo sapien neanderthalis. You can see that it looks a little bit different. Okay?
Yeah.
Any questions?
Yeah.
And that is the end of the test material.